Warm welcome. You're watching Times Now Live Wire with me, Priya Behel, and the story that we're focusing on sets our eyes on the sun. After creating space history with its Chandrayaan 3 moon mission, now ISRO has announced that Aditya L1, India's first space-based observatory to study the sun, will be launched on the 2nd of September, and the time has been set to 11:50 a.m. So countdowns can be set to that time. The launch will take place from Andhra Pradesh's Shriharikota. Aditya L1 mission will be launched by PSLV-XL rocket from Satish Dhawan Space Center, SHAR. Initially, the spacecraft will be placed in a low Earth orbit. Subsequently, the orbit will be made more elliptical, and later the spacecraft will be launched towards the Lagrange point, which is L1, by using on-board propulsion. So now India is all set to take another leap when it comes to space and the missions involved. Now, when it comes to the Aditya L1 mission, one of the major objectives of the mission is to study the reasons behind the formation and composition of solar wind as well as space weather. This will take around 100 Earth days to reach its destinations, but unlike the moon mission, the destination is not the surface of the sun as logic would dictate. Obviously, L1 is going to be a significant step forward in our understanding of the sun. And how will it do that? Deepak, it's over to you for the details.
Well, this is definitely yet another crucial mission that ISRO will be embarking on. We should note that now, if the moon was something that was challenging, one would naturally assume how much more challenging the sun would be. Considering the intensity of the sun in itself, in terms of the heat that it emits, in terms of the quality of the satellite that we should come up with, and more importantly, of course, the PSLV-XL, the same launch vehicle with minor modifications, is going to be used this time. But this time, the distance that it has to travel will be about 4 times compared to the mission to the moon. And more importantly, of course, similar like what we saw for Chandrayaan mission, there will be, of course, after it moves, after the launch that happens, it will move into the Earth's orbit, and from the Earth's orbit, there'll be multiple electrical orbits before there will be an insertion into the solar orbit, and that is where, of course, a crucial phase will lie. And more importantly, now what they're going to study from this mission is going to be important. Be it the 7 payloads that are going to be a part of this particular satellite, which is going to look at solar weather, or space weather rather. It is going to look at the magnetic field around the sun. It's going to study the corona of the sun and various other details, and this will come into come very handy in other missions that ISRO is going to carry out, is what we are learning. But more importantly, it's a mission that of course has been in the making for over a decade now. There were talks about it in 2008 itself, finally it materializing, and right now ISRO once again very confident that they will be able to succeed with this mission, considering this launch vehicle that they're using firstly has already carried out 7 successful launches. Right now it's going to be embarking on the 8th, and they are hopeful that they will be able to do another successful mission. But about 4 months is when people have to wait before they will actually realize the satellite reaching the desired orbit around the sun.
Okay, thank you, Deepak, for those insights. But now I'm joined by the real experts on the issue. J.N. Ravi, former scientist at ISRO, who has been a part of several GSLV launches as well as Chandrayaan 1 study phase, is with us. Welcome, sir, to this broadcast. Girish Linganna, who's an aerospace and defense analyst, also joins us. Welcome to you as well, sir. Now, Mr. Ravi, first coming to you. There has been this sudden newfound interest in astronomy. Now, tell us in simple, basic terms, what is the purpose of this mission to the sun, why it is not actually going to the sun, and why it is going to be extremely significant?
Yeah, so you have rightly pointed out, this is not a landing mission on sun. Obviously, it is not possible. And sun is such a large object, so that wherever we are going, that Lagrange point 1 is good enough to study sun. Whatever we are focusing here is 3-4 parts. One is the sun is having a photosphere, and then there is a corona that is like a crown. You have the solar flares coming out of it. So that is the primary part of the study. That is the coronal heating and the solar wind acceleration, that is the solar wind that emerges from the corona. And we are also having a solar atmosphere. So sun is having an atmosphere also, like where the less dense gases are surrounding the sun. So solar atmosphere will be studied. And the solar wind is the primary thing. So both the temperature anomalies in the solar wind, the temperature distribution, as well as the acceleration of the solar wind, that is all being studied, because the solar wind is the primary factor of the weather in solar system. So, for example, the whatever the winds means the gaseous ejected from the solar surface that go pass through all over the solar system. And for example, on Earth, when it falls, you get the corona, this northern lights, and it is also affecting the satellites and spacecraft traveling through the solar system, including the Chandrayaan 3. All the Chandrayaan 1, for example, had some kind of an impact with the solar wind when it was operational. So it is important for the scientific community, including ISRO, to study the solar wind, its patterns, etc., properly. Okay. So that is one of the important mission. Then there is a coronal mass ejection. These are like solar flares that comes out occasionally, like whatever solar telescopy that we have. People with a lot of enthusiasm study the solar flares. One solar flare can be like a huge fire-like kind of formations on the surface of Earth, which sometimes the surface of the sun, bigger than Earth itself. So those also we'll be studying. That is called the CME.
Mr. Lingana, all these studies and the data that will be sent back, how can it be put to use?
See, this is we get the real-time data. As our scientists told, there is a lot of things to be studied. See, the sun has got basically 7 parts. The sun is having 7 parts, out of which 3 are the inner parts and 4 are the exterior parts. That is, it starts from the exterior parts is photosphere. The sun's core temperature will be somewhere around 150 lakh degrees centigrade. The sun core, the center of the sun. By the time it comes to the photosphere, that is a 4th layer, it drops down to 5000 degrees centigrade. And when it comes to corona, the outer surface of the sun, again it goes to nearly to 2 lakh degrees centigrade. So this temperature gradient variation they are going to study. That is one thing. And the distance between the sun and the earth is around 15 crore kilometers. But where we will be placing Aditya L1 is at Lagrange point L1. That is actually 15 lakh kilometers from the earth. So we will be not near to the sun. We will be somewhere around 1 crore 35 lakhs away from the sun, what we will be studying the point. And Lagrange point is such where there is a gravity, there is a nullification of the gravity between the sun gravity and the earth gravity, and our satellite will be hovering over that orbit, that is called as the halo orbit. From there we have got 7 payloads, and through these 7 payloads we will be studying various activities, as I told, temperature gradient variation and solar flare or solar wind, which falls onto the earth, where our communication systems can be affected, our electromagnetic, all the data, sensors and such things gets affected. Moreover, our satellites, which we are moving more than 50,000 crores of space society. India alone is having about so much of satellite assets on the above our Earth. So even those satellites can burn out with this solar wind. So to study all these effects, we are going to study this through Aditya L1 mission.
Okay. Mr. Ravi, now as Sir was explaining, the sheer distance and the kind of payloads that this is carrying, how much more difficult it is going to be as compared to Chandrayaan, which has 2 payloads and it was much closer to the Earth. What are the chances of success? Are there going to be any last-minute jitters here as well?
I don't really think, because the distance-wise, the Lagrange point L1 is 4 times farther than Moon. But there is no landing, or there is no fine landing related problem.